We'll start the class in 5 minutes.
Okay.
Okay, let's start the class. I welcome you all to NPTEL discussion session of FEM course for the January to April 2025 batch. So this is the week number 8. We have completed 7 weeks tutorials. This is the 8th week. Let's start. So till now we have submitted the 7 assignments. I'll present today the solution of assignment number 7 along with the questions which are relevant for the assignment number 8. So this is the question number 1 for the assignment. So it says let a polynomial approximation for field variable in FEM is this. So how we have to solve it? We have to make a Pascal triangle which says 1x x square xy y square x cube x square y x y square and x cube or y cube. So when we see this fxy which is given, it contains c naught. Okay, so this line is covered. X and y both are covered, so this line is covered. xy, x square and y square are there, so we can say this is also covered. And the in the cubic terms, x square y is there, these two are there, then these both are there, so all these are covered. So what we can say, the polynomial is complete up to degree number 3. So this same question I have discussed in the last class, so I hope you didn't face any difficulty in solving this question. The second question says, suppose in a finite element discretization, the global continuity is C1. Now say phi is the global shape function and its first and second derivative is shown like this. We have to choose the correct statement. So it is saying that the function is C1 continuous. So did anyone remember what C1 functions are?
C1 is means primary variable and its derivative both are continuous.
Correct, correct. So C1 functions are functions whose derivative exists and is continuous. So for this, if phi is the function and phi dash is the derivative of is this, so both phi and phi dash will be continuous. So what we can say, the answer is B. Okay, question number 3. You have given a CST element and you have to solve the questions. So the first question related to this is, suppose that the displacement at any point within the element can be expressed by this. This is nothing but just we have seen n1 u1 and 2 u2. It is written same like this. Then it says ui are the nodal displacement, that's okay, no problem. Phi e are the shape function which I have written it here is n1 and 2, just for your reference. And what will be the expression for shape function? So you have to calculate the shape function for it. So how to calculate the shape functions? This is your triangular element. This is 1 2 3. You have to get the shape functions of it. So what you can do, you can you have to get the expression for shape function of phi 1, means n1 you have to get. So for that, what you have to do, you have to make a line like this crossing from two nodes, and you have to get the equation of this line. So what will be the equation of this line? This is 0 0. This is 2 is 10 comma 0, and third is 0 comma 10. So this equation will be, we can solve it writing y minus 0 is equal to 0 minus 10 on 10 minus 0 x minus 10. I've just written the linear equation of a line by 2 points. So when you solve it, you will get it as y minus x minus 10. So you can write this as minus x minus y minus 10 equals to 0. So you get the equation of this line. Now equation value of equation at point 1. So what is the point? It's 0 comma 0. When you put the value of 0 comma, you will get the minus 10. So your n1 will be minus x minus y minus 10 divided by minus 10, which says this will be plus, this will be plus, so it will be x plus y minus 10. Okay, or we can say it as, no, here now by putting it will be plus 10, so it will be plus 10. Now it will be minus x minus y. Why you can do it, you can do 1 minus 0.1 x minus 0.1 y. So if we check the solution, A is the answer. Is it clear? I mean, this is the process how to get the shape function for 2D element. I have solved it for previous questions, previous assignments as well. So question number 4, what it says? It says what will be the expression for displacement at coordinate 2, 5 when the within the element. So it's the linked question. You have to find the u for this. So it is simpler one. You have just write n1 u1 plus n2 u2 plus n3 u3. Now we have calculated n1. Now we want n2 and n3 as well. So this was our element, which is 1, 2, 3. Now we have calculated n1. Now to calculate n2, you can make this line, which you know will be x is equal to 0. For n3 you can make this line, which will be y is equal to 0. So what you can write, n2 will be x and n3 will be y. Also we have to put the equation at that point as well. So this is 0 comma 0 and this is 10 comma 0 and this is 0 comma 10. So let's start with n2. When we write n2, this horizontal line will be in considered. So no, for n2 this vertical line will be considered, and this will be x, and at that point, which is 10, so it will be divided by 10. For n3 will we have y by 10. Is this clear for all? If not, I can explain it further, but it's a simple thing. I think you can grasp it. So now what we have n1, n2 and n3. Just we have to put it in the equation. So n1 is 1 minus 0.1 x minus 0.1 y of u1 plus n2 is x by 10 of u2 plus y by 10 of u3. Now what it is asking, we'll solve further, then write. So it is u1 minus 0.1 x u1 minus 0.1 y u1 plus 0.1 x u2 plus 0.1 y u3. So how are the options given? It is based on, okay, so x and y coordinate are also given as 2, 5. So we can put that 2, 5 we have to put. So u1 minus 0.2 u1 minus this is 5, so 0.5 u1 plus x is 2, so 0.2 u2 plus 0.5 u3. So u1 we can take together. So 1 minus 0.8, this will be it will be 0.3 u1 plus 0.2 u2 plus 0.5 u3, 0.325. So 0.325, all are positive, so you check, answer is C.
Sir, can you repeat how do we get n1?
N1, okay.
With this method, I use the longer method actually.
Okay.
By framing the equation and finding the inverse and all.
Okay, no problem. So in 2D, there is a way to solve the shape functions. Like if this is the shape, this is 1, this is 2, this is 3. So what you have to do, if you are finding n1, you have to make a lines which cross other nodes but not this node. So what best you can write is this node, this line.
Yes.
So this line cuts other two nodes and not this node. So what is the equation of this node? Coordinate is 0, 0. This is 10, comma 0 and this is 0, comma 10. Now you have to get the equation of this line. How you will get it? This is y
Yes.
minus 0 is equal to, see I have done here. So y minus 0,
Yeah, I get it.
this is the equation. Now this you got the equation of this line. Now what you have to do, the if you are finding n1, this equation should give you the value of 1 at this coordinate, because
Yes,
it is
correct.
the property of n. So what we do, we find the equation of the value of this equation at that point. So when you put this 0 and 0, you will get 10. To normalize it, what we'll do, we'll normalize this equation by dividing by plus 10 and you will get the n1.
Okay. Okay.
So it's a way of
Fine.
solving it in 2D.
Okay.
Similarly, if you see for x2 and x3, I have done the same things. Now for 2, you have to cross the line by this. So this is the line.
Yes.
For 3, you have to cross this line. The equation is fairly simple, which is y is equal to 0 and x is equal to 0. The amount 10 is coming from the putting the values and normalizing it. Is it fine?
Clear. Yes. Yes. Yes.
Okay. So now question number 5. It is also the linked question. So it says, suppose strain along the x direction is this, which is the obvious thing. And what is the expression for epsilon xx at any inside the element? Okay. So this is also the same thing. Exx is equal to del n1 by del x u1 plus del n2 by del x u2 plus del n3 by del x u3. So I have replaced phi by n for better understanding, but that's the same. You can write phi as well also. So n1 we have, what n1 we have? We know the n1 is this. So when we derivate this equation with x, we'll get minus 0.1 only. So this will be minus 0.1 of u1 and n2. What is the n2 we have? N2 is x by 10 and n3 is y by 10. So when you derivate n3 with x, you will get 0. For this you will get 0.1. So this will be, n2 will be 0.1 and this will be 0. So finally you get 0.1 minus 0.1 u1 plus 0.1 u2. So the option you check is A. Now let's go to question number 6. What is the correct option for CST element? So I think the same questions I have done in the last class. So what this question says, the question number 5 will, so displacement and strain are constant within the element. Yes, this can be correct. No, this is correct. Others let us also see. Only strain is constant within the element. No, displacement is also constant. Only displacement is constant within the element. No. So the answer is displacement and strain are constant within the element. So the question number 7, consider the 9-noded quadratic Lagrangian element in natural coordinate system and answer the following. So what we have to do, we have to find the node 3 shape function. So there are different method. Since I am covering this line method, I'll cover with that only. That will.
Sir, one doubt, but in the assignment solution, it's given for the previous question.
Previous question, what it is given?
Only strict constant within the element. Displacement is variable.
So they have given the strain only constant.
The displacement should be variable, no, because we make the equation in the form of.
Oh yes. Sorry, I think. Did they give this answer number A?
No, I had given answer B, and it is correct.
Okay, so
Sorry,
I
it's correct.
okay, okay.
I don't know. Means it's
It's constant strain triangle, na? So
yes.
it will be only strain is constant. I think I misjudged it. Displacement will not be constant. Thank you for telling me, correcting it. So only strain will be constant. Yes, the answer will be B. I think I missed something in the assignments. Okay, so solving this shape function for node 3. Okay, so let's start. There are different methods to solve this, but I'll use that line method only. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now your natural coordinate system is Z. This is I and neta. So you have to find N3. So if you use the same trick, so what we can do, we can get one line like this, like this. We can get one line like this, and one more line we need for 5 6, and one line for we need for 2 3. So these are the four lines we have to make to cover, to cut whole all the nodes. So let's write the equations of these lines. So first this line will be neta is equal to 0. For this line it will be psi equal to 0. Now this line will be neta is equal to plus 1, and this will be xi is equal to minus 1. So all you have written the equations. Now you can write the equations in multiplication form. So equations will be, one will be xi equal to 0, one will be neta is equal to 0, other is neta minus 1, and other is xi plus 1. Psi plus 1. So these are the equation. Now what you have to do, you have to put the coordinate of this point. So what is the coordinate of this point? This will be minus of 1, no, it's plus 1 for xi and minus 1 for neta. Okay, so you have to put 1 comma minus 1 in this. So when you put this 1, this is minus 1, this is minus 2, and this is 2. So it is coming plus 4. That's correct. So for n3, what will be the solution of the shape function? It will be this divided by 4. So I hope the option is there. Option is C. Yes, it's the correct. You see the option is 0.25 and all. So option C is correct. This is correct. This is clear to everyone.
Yes, sir.
Okay. So, now what they are asking, they are asking shape function for node number 5. So which is the node number 5 is the center one. Okay, let's make the figure again. 1 2 3 4 5 6 is this, 4 5 6 7 8 9. Now to find the solution for n5, this is the xi coordinate system. So you need this, you need this, you need this, and you need this to solve the problem. So this is neta is equal to plus 1, this is neta is equal to minus 1, this is xi equals to plus 1, and this is xi is equal to minus 1. Okay, write the equations. So this will be xi plus 1, xi minus 1, neta plus 1, and neta minus 1 equation. Okay, so now we have to, so what is the coordinate of this system? This 5 point is 0 0, and you put the point 0 0, it will give me 1 minus 1 1 minus 1, so it will be 1. So what will be the n5? N5 will be xi plus 1, xi minus 1, neta plus 1 and neta minus 1. So xi square minus 1 neta square minus 1 divided by 1. Divided by 1, this will be xi square minus 1 and eta square minus 1. So the option is D. Now question number 9. So what it says, consider a four noded element for which x1 x and y are the coordinate, xi the natural coordinates. If the transformation equation is given to you, y x is this, y is there, you have to find the Jacobian. Can anyone recall what is the Jacobian matrix?
It's del xi into d xi.
You just have to give the Jacobian matrix.
Yeah, del y by del xi.
Then here it will be
del x by del eta.
Del y by del eta.
Del y by del eta.
Okay, so this is the Jacobian matrix what you have. Now x is given. X is given as 4.5 plus 4.5 xi, and y is given as 6.5 plus 6.5 meter. So we can calculate del x by del xi. It will be 4.5 del y by del neta or del xi only. Del y by del xi will be 0. Del x by del neta will be 0 and del y by del neta is 6.5. So when we put the value, it will be 4.5 0 0 6.5, and since we need the Jacobian, so we have to take the determinant of it, this. So when you take the determinant, you will get 4.5 into 6.5, and the answer will be 29.25. So if you check the question, so it's on the same page, so the answer is B. Now question number 10. We have to identify the correct statement for given elements. So figure A is 9 loaded Lagrangian element. So if we check, there's 9 nodes are there, and all the vertical lines having the same nodes. So yes, it is Lagrangian. And 8 noded is serendipity element. So yes, 8 nodes are there. So this is the correct option. We don't need to check others as well. Also, we'll get this only. So I've covered the assignment number 7 questions. Let's start with the questions which are related to week 8 now. So this is the first question I have taken. So it says, suppose strain within 4 node quadrilateral element in finite element can be written as this, where B is the strain displacement matrix, delta is the nodal displacement vector. You have to find the dimension of B. So 4 noded quadrilateral elements, so we'll make this as 1 2 3 4. Okay, so for 4 nodes, since it's 2D, we know each node will have 2 degree of freedoms, so total 8 degree of freedoms. So we know the equation it as epsilon of the element, B of the element, and delta of the element. So you know now that this is 8 cross 1. Now epsilon, since it is it is the planar element, so it will be epsilon xx, epsilon xy, and epsilon yy. So the vector, the dimensions of it will be 3 cross 1. So when you have 3 cross 1 here and you have 8 cross 1 here, so simply you know that it should be 3 cross 8, otherwise the multiplication will not exist. So simply your B matrix should be 3 cross 8. So the option is D. Is it clear with everyone, or was I fast?
Yes, it's clear.
Okay, let's take question number 2. So suppose there is a CST element which is shown in this figure, for which nodes are shown in blue dots. Okay, xi1, xi2, xi3 are the shape functions, and shape functions the value is given, alpha, beta, gamma are also given, and you have to find the ratio of shape functions. So let's start solving the problem. So xi I is given as is it's given as 1 upon 2 AE alpha I plus beta I x plus gamma I y. Okay, then if you write it as 1 2 3, this will be 1 upon 2 area of element alpha 1 beta 1 x plus gamma 1 y. And then you can write this for all, beta 2x plus gamma 2y, and psi3 will be 1 upon 2 AE alpha 3 plus beta 3x plus gamma 3y. Now you have to get the value of xi1 by xi2, you need to know the value of alpha beta. So we'll compute that. So or what we can do, we can write a term by xi1 by xi2, and when we'll divide it, we'll get alpha 1 plus beta 1x plus gamma 1y upon alpha 2 plus beta 2x plus gamma 2y. So this is the answer we'll get. We need alpha, beta, gamma. So alpha I, which is given in the question, is this. So we'll write here xj yk minus xk yj. Correct. So for this node 1, the value is 1 comma 1, as you can see here. So we'll write the alpha 1, which will be x2 y3 minus x3 y2. Is it fine with everyone? X2 y2 y3 and y2 x3 y2.
Yes, yes.
Okay, now we'll check the value, which is 5 4 minus 2 comma 1, which will be 18. So 5 cross 4 is this and this, you will get the value. Now similarly we'll calculate alpha 2 as well. Alpha 2 will be, if you will write it properly, node 2 is 5 comma 1 and node 3 is 2 comma 4. So we have all the values here. Now to calculate x2, it will be x3 y2 minus x1 y3. Okay, so x3 is 2 comma 1 minus 1 comma 4, which is minus 2. Okay, now you have the value of alpha. Let's calculate the value of beta now. So beta I is given as, I think beta j is given as beta I. Okay, beta I is given as yj minus it's yk. So beta 1, if you calculate the beta 1, it will be y2 minus y3. So it will come out to be 2 minus 4, which is minus 2. I'm taking using these coordinate only. And beta 2 will be y3 minus y1, which will be 4 minus 1 to 3. So now we have alpha also, we have beta also. Let's calculate gamma now. So how gamma is given as, gamma I is given as minus of xj minus xk. So we'll check once. Yes, it's xj minus xk with a minus sign. So it is written like this. Now let's calculate the gamma 1. When you go to calculate gamma 1, you will get x2 minus x3. We're using the coordinate system I have shown you in the previous slide. It's 5 minus 2, which is minus 3. Now gamma 2 will be minus of x3 minus x1. When you substitute, you will get minus of 2 minus 1, which is minus 1. Okay, now you have all the things to get your answer. So I'll write the xi1 by xi2 again, which is alpha 1 plus beta 1 x plus gamma 1 y divided by alpha 2 plus beta 2 x plus beta 2 y. So when you substitute the values, you'll get 18 minus 2x minus 3y divided by minus 2 plus 3x minus y. So the answer you have to check. It is answer number A. Okay. Some mathematics. Are you all with me? Is it clear?
Yes, sir.
Just the mathematics I have done. Okay. Now let's focus on the question number 3. It's a thermal problem, a temperature problem. So suppose a 2D isotropic elastic body was in temperature of 30 degree. Okay. Suddenly the temperature is extended to 600 degree. Now the coefficient of thermal expansion is given along with the Young's modulus and the Poisson's ratio. What are the longitudinal and shear components of thermal strain considering plane strain condition? So one thing is that this thermal expansion things been covered in the class this week.
Yes, it was covered.
And what about the plane?
Poisson equation was covered.
Okay, what about the this plane strain and plane stress conditions?
No, those were not covered, I guess.
Those were not discussed. Okay, no problem. So I'll tell you when we apply the plane strain condition, uh, we get epsilon xx, epsilon xy, and epsilon yy. So you are all full matrix epsilon xx, epsilon yy, epsilon zz, epsilon xy, epsilon yz, and epsilon xz. So since it is plane strain, so third component will be 0. So all belonging to z will be 0. So what we'll get 3 components only, which are this for plane strain conditions. So for plane in this strain condition, when you write epsilon xx, epsilon yy, it will be covered in the next week, no problem. Epsilon yy and epsilon xy. So when you write the condition, it will be D. D acts as the modulus of elasticity matrix in the plane strain condition. So alpha delta t, and 0. So this is the stress only. You in strength of materials, you know that epsilon is equal to alpha delta t for the case of that for the case of thermal stresses. So what I have written, epsilon xx, epsilon yy, epsilon xy. For plane strain, we know it is 1 plus mu d, and here it will be alpha delta t, and 0. No, what you say, no thermal strain problems. So when you substitute the values which are given, 0.24 is the mu, and alpha is 10 power minus 5, and for delta t, the temperature has went from 600, and it was previously 330 degree. So it's 600 minus 30, so it will be 570 degrees Celsius. So this is 570, 10 power minus 5 into 570, and 0. So you'll get the answer as 1.24 into 10 power minus 5 into 570, 10 power minus 5 into 570, and 0. Let's check what answer it is given. So 7.07, when you multiply this constant, you will get 7.7, and the answer is C. So you have longitudinal thermal strain of this, but thermal shear strain is 0. Okay, so let's go to question number 4 now. It's a big question. Suppose a thin elastic square plate is compressed with a uniform varying load on left edge, which is this. The body is discretized with two CST elements. One element is this, second element is this. The modulus of elasticity and Poisson ratios are given. The thickness of plate is also given. And you have to consider the plane stress condition and answer the this problem. Okay. So let's start solving. Let's take what is the ask. We'll see that also. In FEM, okay. In FEM, the elemental stiffness matrix is this. What is the strain displacement B we have to calculate for element number 1? The question is clear to everyone? Is anyone still? I can give you time for reading. We have to calculate the B for this element number 1 in which the loading is acting. Okay, let us start this solving the question. So the element is like this. So 1 is 0 comma 0, 2 is 100 comma 0, third is 100 comma 100. So this is element number 1. Now we can say the total degree of freedoms are 6 degree of freedoms. So the B element will be 3 cross 6. Is it fine with 3 cross 6? Can anyone tell how it has come? Or is it clear? Okay, I'll take that it is clear. So when we calculate B of element, we have a matrix like this: beta 1 0, beta 2 0, beta 3 0, and then 0 gamma 1, 0 gamma 2, 0 gamma 3, and here it will be gamma 1, beta 1, gamma 2, beta 2, gamma 3, beta 3. And where beta I is yj minus yk, and gamma I is equal to minus xj minus xk. So we have to find the values of beta and beta and gamma to get the solution. So beta 1 will be y2 minus y3, which is 0 minus 100. That's minus 100. And beta 2 will be y3 minus y1, which will be 100. And beta 3 is y1 minus y2, which is 0. Now let's calculate gamma similar way. So gamma 1 will be minus of x2 minus x3, which will be 0 by putting the coordinate system. Gamma 2 will be minus of x3 minus x1. Then it will be minus 100. Then gamma 3 will be minus of x1 minus x2, which will be 100. Okay, let's calculate the area as well. So area will be half base into height, which is directly 5000. Now let's calculate the B element by substituting the value. So it's really 1 upon 2 into 5000, and we make the matrix, it will be minus 100, 0, 100, 0, 0, 0, then 0, 0, 0, minus 100, 0, 100, 0, minus 100, minus 100, 100, 100, and 0. I've done nothing, but I have put the values of beta and gamma and got the matrix. So when you solve the matrix, you will get it as minus of 0.01, 0, 0.01, 0, 0, 0, 0, 0, 0, and this will be minus 0.01, 0, 0.01, 0 minus 0.01 minus 0.01, 0.01, 0.01 and 0. So this is the B, what is asked in the problem, and you check the answer will be C. Is it fine with everyone? Is it clear? Okay, I hope it is clear. Okay, now let's start with the question number 5, and this is the if you now the same question is given in this assignment, not the same, but the type is same, so it will be very helpful for you to do that question. So let's start the question. It says, consider the following linear isoparametric mapping from parent domain to physical domain. Okay, location of quadrilateral in physical domain is shown below, and now answer the following question based on the isometric parametric mapping. So this is the original domain. This is the isoparametric formulation, and you have to find the, with the help of isoparametric mapping, x y can be written in the following parametric form. So we have to give the function with this mapping is being done. So for that, what we have to do, we have to find the shape function of this. Let's start doing that. So this is the general isoparametric element we have, and 1 2 3 4 are the coordinates. And 2 4 4 1. So from this we know x1 is equal to 2, x2 is equal to 4, x3 is equal to 4, x4 is equal to 1. Similarly, if you write for y, I think yes, y also we can write is y1 is 1, y2 is 1, y3 is 4, and y4 is 2. Are you guys with me? Following?
Yes, sir.
Okay. So now we have to find the n1 in terms of xi and eta. So I'll write directly the shape function. It is not tough to be found out. It's this. Now you must have seen it many a time. So this is 1 plus xi, 1 minus neta divided by 4, and 3 is 1 plus psi, 1 plus theta divided by 4, and n4 is 1 minus psi, 1 plus theta divided by 4. Okay, so how you do a parametric formulation? You write like this. X4 x4. So let's substitute the value. We'll get x is equal to 1 by 4, 1 minus xi, 1 minus neta into 2. 2 is the value of x, 1, then 1 by 4, 1 plus xi, 1 minus neta into 4. 4 is x2, then 1 by 4 of 1 by xi, 1 plus neta into 4. 4 again is the x3, and 1 minus xi and 1 plus neta into 1. Okay, so we have written this. Let's solve this. So this we can get 1 by 4 common out, and 1 minus neta, then it will come out to be 2 minus 2 xi plus 4 xi. Now it will be plus of 1 plus neta. So we have taken out common 1 minus xi neta and 1 plus 1 plus neta. Now it will come out to be 4 plus 4 xi plus 1 minus xi, whole curly bracket. Okay, when you solve this, you will get 1 by 4 of 1 minus neta with 6 plus 2 xi, then plus 1 plus neta. With this you will get 5 plus 3 xi, then curly bracket. Okay, so when you solve further, you will get x as 1 by 4 of 11 minus neta plus 5 xi plus neta xi. Okay, so this is the x interpolation. Let's do the same thing for y as well. Okay, so we'll write this as 1 by 4 1 minus psi 1 minus neta into 1 plus 1 plus xi 1 minus neta into 1 plus 1 plus xi 1 plus neta equals to into 4 plus 1 minus xi 1 plus neta into 2. Again the same thing I have done, and when you solve it, 1 by 4 we'll again take common as 1 minus neta and 1 plus neta. So this is 1 minus xi plus 1 plus xi okay, then 1 plus neta will be 4 plus 4 xi plus 2 minus 2 xi. Okay, and this is 1 by 5 twice of 1 minus neta plus 1 plus neta 6 plus 2 xi, and you solve it, you will get it as 1 by 2 4 plus 2 neta plus psi plus this. Okay, so this is the final answer for y interpolation, and this was the answer for x interpolation. So when you check the solution, you will see, you will match it, you will get the C as the answer for it. Okay, is it clear? It was little lengthy question.
Yes.
Okay,
Clear.
thank you. Now let's go to question number 6. Okay, so what we have to do, we have to find the determinant of the Jacobian. So we know what Jacobian is. It's del x by del xi, del x, so del y by del xi, del x by del neta, and del y by del neta. Okay, so now we have x and y with us, so let's write here. If the question is linked with the previous one, so let's write the x and y which we have got. So first let's do the del x by del xi. So what we'll get, we'll get 5 by 4. This will be 0, this will be 0, only this term will be there, this term will be there. So 5 by 4 plus neta by 4. Similarly, if you do del x by del neta, what you will get? You will get this term and this term. So it will be minus of 1 by 4 plus xi by 4. Correct. Now let's do the same with y as well. So y we know is 1 by 4 of 4 plus 2 neta plus xi neta. Is it correct? 4 plus 2 neta plus xi, oh it's 2, it's not 4. Okay, so when you do this, you will get del y by del psi as this and this. So it will be 1 by 2 plus neta by 2 del x del y by del neta will be this and this. It will be 1 plus xi by 2. Correct. Let's substitute this in Jacobian matrix, and we'll get 5 by 4 plus neta by 4. I'm just substituting the value. 1 by 2 plus neta by 2 minus 1 by 4 plus xi by 4 and 1 plus xi by 2. So they have asked the determinant of the Jacobian. So let's take the determinant. So it will be 1 by 4 of 5 by neta into 2 by xi into 1 by 2 minus of 1 by 2 1 plus neta and multiply by xi minus 1 into 1 by 4. Is it correct? You all are with me? Okay, let's go with Jacobian solving. So it will be 1 by 8 of 10 plus 5 xi plus 2 neta plus neta xi minus xi plus 1 minus neta xi plus neta. So when you the final, I'll write the final answer. I'll skip some of these steps. It will be 22 plus 8 xi plus 6 neta. So the answer is B. Oh, the answer is B. I think this is the simple question you must have understood. Let's go to question number 7 now. Same. I've taken the same question as given in the assignment. Just the function is changed. So it is saying that suppose we have one integration in physical domain over the quadrilateral, and we want to transfer the integration to parent domain to carry out the numerical integration. What will be the following integration in the parent domain? So can anyone tell me what we have to do in this question? Just a simple 2-3 lines.
First of all, I think we have to use the isoparametric formulations and then use the Gaussian quadrature to do the integration.
Okay. Yes, correct. So okay, why? But can't we solve by this x and y coordinate system?
Yes, we can do obviously with x and y also. So if we know the limits of the quadrilateral that we are drawing, and we form the double integration for this.
Yes, we can do this, that as well, but isoparametric formulation is way cheaper, way easier than that. So we do it like that. So in this question, what we'll do, we'll write I as this will be when we convert this into isoparametric formulation, xi and eta. So we know that this is -1, this is +1 for xi, and this is -1, this is -1, this is 1 plus 1, and this is -1 comma 1. So it varies from -1 to 1. So directly what we can give the limits as -1 to 1, -1 to 1, x based on xi and eta, y xi and eta. Since here it is a square, so we'll make it as a square, and while converting we have to make a determinant as well, and t xi d eta. Okay, now you have written like this. Now what we have to do, you have to give the formulation. Is it connected with the last question? 7 to 10. Okay, then it's fine. So we have to solve according to that. So now we have calculated everything in our previous steps. So minus 1 to 1, minus 1 to 1. We have calculated x as 1 by 4, 11 minus neta plus 5 xi plus xi neta. This is x, and when we'll do y as also, we'll put 1 by 2, 4 plus 2 neta plus xi plus xi neta, and that to all whole square. And we have to multiply with Jacobian as well. So 1 multiply 1 by 16, 22 plus 8 xi plus 6 neta d xi d neta. Okay, so I think this is only the solution. So okay, so when you take it out, 1 by 16 into 4 here, 4 here, so it will go up to 256, I think. Yes, so which is the option? A is the option. So they have written in the form of integration only, and they don't have the solved it yet. Okay, so we have to solve it here. So till this question they have made you to form the integration, and now they are saying you to solve, and that too with 1 point quadrature rule. So I'll tell you a few things about it. So if this is the function, so when you solve it by Gauss quadrature, you get this solution. You have to solve it like this. And if you are using the 1 point Gauss quadrature, you will write the one function only. And by solving 1 point quadrature, what you can get exact, if fx is linear polynomial, you will get the exact solution. And let us if we use a 2 point Gauss point rule, we'll have to split the function into two parts. And in this case, if fx is of up to 3 degree, we can get the exact solution. This is the thumb rule which is established. So here they are asking you to solve for 1 point quadrature. So the solution will be W1 F1 only. And we know for 1 point Gauss point, the point is xi 0 and neta 0. And this sampling factor, the wave function is also 1. So we'll use that in the integration. We'll find the value of function at 0 0. So we have got the function. We have got the function in the last problem like this. So what we'll do, we'll put this as 0, we'll put this as 0, we'll put this as 0, this as 0, this all 0. So what are the constant terms which will be remaining? This is 1 by 4, 11 into 1 by 2 into 4 whole square into 1 by 16 into 22. I have taken all the constant term and made all xi neta as 0. And when you solve it, you will get 11 by 4 into 4 into 1 by 16 into 22. And when you solve it, you will get for 15.125. 126 or 5, it is 125. Okay, so the answer is B. Is it clear with everyone, the 1 point Gauss quadrature rule?
Yes, sir.
Okay, now let's do one more question where you have to solve the Gauss quadrature with 2 Gauss point and evaluate the following. Let's take the first question first, where it is saying integrate from minus 1 to 1 cos of s by 2 ds. So this Gauss point quadrature is covered in the class now?
Yes, it is covered.
Okay, so I'll solve this problem with 2 point Gauss quadrature rule. So what we know about the 2-point Gauss quadrature, that in that case the sample points are, one point is minus p and second is plus p, where we know p is 1 by root 3. Also we know that the weight functions attached to it are 1. So when you are writing the problem, we can write this as cos of s by 2 ds, and it is equal to w1 phi 1 plus w2 phi 2. So two terms I have written because I am solving it by 2-point problem. So since we know that w1 is 1, w2 is 2, we can directly write this as phi 1 plus phi 2. Okay, now we have to compute the value of phi 1 and phi 2. Okay, can anyone tell me what is phi 1 and phi 2?
It is this form 2-point quadrature.
Anyone? Others can also answer. Anirudh, Mahesh, Ramesh, anyone?
1 and 1. I think it's 1 and 1 plus minus 1 by 3. It's
No. How to calculate phi 1 means phi 1, what phi 1 is denoting?
is basically the shape function.
No, it's not the shape function. Now you are away from the shape function. You have solved full FEM problem. Now you are solving this integration.
Okay.
So tell me what the general rule of solving a Gauss quadrature.
Oh, this is the value of the function in that point.
At that sample point.
Yes, sample
yeah,
point.
Correct. So phi 1 is the value of this function at s1. Phi 2 is the value of this function at s2. Correct?
Yes.
Got it? Okay. Now let's find phi 1. So phi 1 will be cos of s by 2 at s is equal to s1. Don't get confused with phi 1 as shape functions. Now when you start doing the integration, this means that you have solved all the FEM problems. You are just getting the results. Okay. So cos s by 2 at s is equal to s1. S1 means minus 1 by root 3. You will get some value. Okay, let's not touch that right now. Okay, so this will give you cos of minus 1 by 2 root 3. Similarly, phi 2 you will calculate, which will be cos of s by 2 at s is equal to plus 1 by root 3. So it will become cos of 1 by 2 root 3. So simply we'll put the values here. I will be cos of minus 1 by 2 root 3 plus cos of 1 by 2 root 3. So when you solve it, you will get a 1.917. So it's just a way of solving the integration, and I've shown you, instead of solving this cos function with integration rule, you can directly solve it by writing a simple term and get to your solution. So the question says
I have one question.
Yeah, tell me.
For polynomial, we know that the exact integration is 2n minus 1, right?
For what?
For to get the exact integration with Gauss points.
Gauss points.
So that's 2n minus 1 rule.
2n minus 1 rule. Yes, correct.
Right. So for trigonometric function, how do we know that till which point we need to do the?
For trigonometric, you have to check it.
Because there is one means we can convert to Fourier using Fourier transformation.
When you do that transformation, that you will get
that is infinite.
That is infinite, yes. So I don't think I don't know about this. You can solve it this with exact integration, and you can check what the solution is coming. I think this will not be exact what we have got, because it is the algebraic terms are higher, but as you increase the Gauss potential for this, you will get the less error for that, because it is going to higher terms, and we can ignore the higher terms, and the error will be reduced.
X by 2 ds.
Hmm. So since it is having a higher terms, so as you increase
It's coming 1.999974.
See, with using 2 point, you are getting like this. You won't get exact with this method, because the higher terms are also there.
Yes.
But when you use the 3 point, you may go more closer. Let's say we get 1.95. When we use 4 point, we can get 1.97. So you will go more closer to it.
Okay.
So this second term and three term is least significant, so we can take this also as the correct
So
equation.
we have to go with the convergence theory.
Conversion, yes,
Till
yes,
which
because more higher terms are there, so
yes.
you can stop at one or two. Two is fine.
Okay.
So the question, one more question is there, where algebraic equation is there. I'll solve that as well. So the question says the integration is y is equal to 4, y is equal to 6, x is equal to minus 2, x is equal to plus 2. The equation is 1 minus x whole square, 4 minus y whole square, dx dy. Correct? Correct. Okay. So now what we have to do, we see the limits are also given. Here limits are not plus 1 and minus 1. Last question it was plus 1 and minus 1, though we didn't change it. Now you see the limits are also changed, so we have to change the limits as well. So x we know, n1 and 2 in the parametric formulation are this. I'll directly write it. So now x1 and x2 is known as here known, plus minus and minus 2. So we'll put that 1 minus xi with minus 2 plus 1 by 2, 1 plus xi and plus 2. So when you solve it, you will get this. Now since you have got this, you have to change dx and dy as well. So dx is equal to twice of dz. Same thing you have to do with y also. So when you will do y, you will write in form of neta 1 plus neta y2. Then you will write 1 by 2, 1 minus neta into 4 plus 1 by 2 and plus neta into 6. So 4 and 6 are the value of y1 and y2 for the from limit we have taken it. So when you solve it, you will get 2 minus 2 neta plus 3 neta. The solving you'll get 5 plus neta. Now you have to get dy also. Now I'll write first y is equal to 5 plus neta, and when you do it dy, you will get dy is equal to d neta. Simple. Now let's convert the I into the xi and neta form coordinate. So we know neta is equal to minus 1 to plus 1, xi is equal to minus 1 to plus 1. We have changed the coordinate system, and we are getting it 1 minus 2 xi whole square, 4 minus 5 plus neta whole square into 2 d xi d neta. Is it clear till here? How I have written this?
Yes, yes.
Okay. Now the question is saying that you have to solve also, I think. Yeah, we have to solve it also with two Gauss points. Let's solve this. So we know the from two Gauss points, the Gauss points are plus minus root 3 with weight is equal to 1. So let's put this I is equal to, so we are taking, let's take this 2 out first. So 2 is out and we'll put the 1 plus 2 root 3 whole square minus 1 by root 3 whole square, plus 1 minus 2 root 3 whole square minus 1 by root 3 whole square. This is S1 and they will do same for S2 as well. 1 plus 2 by root 3 whole square minus 1 plus 1 by root 3 whole square plus 1 minus 2 by root 3 whole square minus 1 plus 1 by root 3 whole square. Is this step clear? Is this step clear?
Yes.
Okay.
Just putting the values.
Just putting the values, yeah, correct. So when you solve it, it's 2 into 12.44. It will give you 24.88. So we have got the solution for this as well. So this is the basic problems I have taken so that Gauss point quadrature is clear to you all. So let's start with the another question. This we have to distribute the load. Okay, let's solve this problem. The problem says the force F acts on one edge of the plane bilinear element at y is equal to minus b by 2, which is this. This is 0, 0. This is minus b by 2. Okay. What is the 8 cross 1 load vector? So you have to distribute this load on the nodes. So let's start solving the problem. So first let's write the coordinates of each of the nodes. This is 1, 2, 3, 4. This is minus a comma minus b. This is a comma minus b. This is a comma b, and this is minus a comma b. Okay, so we know this is Lagrangian element. With linear function in x and y. Linear because we are having the only one node at each of that, so it is linear interpolated. So I'll write a different way here for finding the shape functions. So ni will be lx into ly, the linear functions. So from we know from the Lagrangian interpolation, Lx will be x2 minus x upon x2 minus x1, and Ly will be y2 minus y upon y2 minus y1. Okay, so let's solve for n1. We'll put the value and we'll get a minus x upon 2a with b minus y upon 2b. When you solve this, you will get a minus x, b minus y upon 4ab. Similarly, we can calculate the others n2, n3, n4 also. I'll directly write the value. This is a plus x, b minus y upon 4ab. n3 will be a plus x, b plus y upon 4ab, and n4 will be a minus x, b plus y upon 4ab. So this is the shape function for this Lagrangian element, 4 node quadratic element. what we have to do, we have to find the load vector. So let's find the load vector. You know the formulation for it is n transpose q dx dy. So since it is the point load, how q can be represented? It can be represented like this: f of delta x minus a and y plus b by 2. Is it clear with everyone, this step? I can repeat this if...
This can you repeat this one? You had explained this before, but again
Okay. So you know this load vector formulation. This is clear.
Yeah, this I know.
This I know.
Spike into
Okay. So
QIDS.
how q you are representing? Q is you have to tell which point this f is acting. So at which point it is acting? Delta at x is equal to a. This point is a comma minus b by 2. So what delta function do? Delta function tell you at x is equal to a, it will be up 1, otherwise it will be 0. Okay. So this f will give you value only at x is equal to a and y is equal to minus b by 2.
Okay, clear.
Correct? So this delta is defined on two variables, which is a comma minus b by 2. So this q is telling you that f is acting at this point. So you will get, whenever you satisfy these two conditions, x is equal to n when y is minus b by 2, this function will be f, otherwise it will be 0. Okay. So in y direction. Okay. Also this is the force in the x direction. This is force in the x direction. So you can write qx. If you write force in y direction, it will be qy is equal to 0. So in y direction, if you write the force vector, na, it will be 0, 0, 0, 0. Now, but what we have to find? We have to find in x direction. So you have to... Okay. Now we know when we solve this delta integration, what we get? We get the value at that point. So it will be p and transpose at x is equal to a, y is equal to minus b by 2. Okay, how you have got this? Do you know or should I tell?
It is better you...
Okay, no problem. When you integrate p delta x this, so this is the property of this delta function, that when you integrate it, the result will be p at x is equal to a. You don't have to solve full, just you have to put x is equal to a and you will get this value. Okay. So here n was the, this is p will be p, but n is the having the x, y and y terms. So what you will get when you will integrate this, n transpose p delta x minus a and y minus b by 2 dx dy. So p is constant here, so it can come out, and n transpose, whatever it will do, it will give you the value of at x is equal to a by 2 and y is equal to b by 2. So this is the basic property of delta functions. Whenever it is applied and integrated, you don't have to integrate anything, you just put the value at that point. So how this is happening, I'll tell you that as well. Since you have taken, let's say you have taken a function, and you are saying that x is equal to a, it is going at this. Let's integrate this function. So what integration it is getting? 0, 0, 0, 0, 0, and this point this is getting 1, but at 1 and this is all 0. So at x is equal to a, what is the value of this function attached to it will be the area under this. Is it fine?
Yes, it's clear.
So the area under curve is only this point, which is the value of that, which is multiplied with this. So you will get this out as the integration. So when you will get this out as integration, you can write n1, n2, n3, n4 at that value at x is equal to a and y is equal to minus b by 2 multiplied by f. So when you will put that value, n1 will be, you have calculated this, n1 will, x is equal to 8 will be 0, n2 at n2 will give you some value, and n4 will give you 0 because x is there. You will put a and it will become 0. So when you put the values in it, you will get 0, 3 by 4, 1 by 4 and 0 into f. So force in x direction is 0, 3 by 4f, 1 by 4f and 0. Since it is asking you 8 cross 1 load vector, so it will be, I'll put in next slide. So 8 cross 1 load vector will be, so for 8 cross 1 you have to include x forces also, you have to include y forces also. So this will be 0, 0, 3f by 4, 0, f by 4, 0, 0, 0. So I have included xy, 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 xy for this. So it has become 8 cross 1 load vector. So what you have done in this problem, the force was acting at minus a and a comma minus b by 2. So you have distributed this load to all the nodes which are there. And you can see that since all nodes are far, wait, all nodes were far, so nothing is contribute, this force is not contributing in other nodes, but it is contributing in this 2 and 3 only. Okay, is this clear?
Yes.
Okay.
Just coming like the reaction in simply subordinate.
It will come like that only, because what it is doing now, if you are doing like this, it is like this. So what it will support this like this. So it's just like that, but to show full how it is being done, this is the procedure. So
Okay.
now if when you are solving, you can directly know that if you this force is acting, you can directly attach two loads like this, and which will be the reactions.
Okay.
Okay. I can do one more. What is this question? I think this is all for today. I hope you have got some new question. Today I have taken more questions related to question number, the assignment number 8, related to that and others also. So I hope you have got some good knowledge about it. Was it clear, today's lecture?
Yes, it's clear.
Okay.
But in this week's lecture, no, there is in the last lecture, the faculty was using some codes for solving the thermal problem.
Okay.
So we said that it will be uploaded on the forum,
Okay.
but I couldn't see the code being uploaded.
I don't think they have uploaded till now.
Yeah. Means he said in the lecture also that it will be uploaded on the forum.
Okay. Let's see. Means I haven't got that course yet, so I also don't know about this.
There was maybe two codes were there, one for triangular element and one for quadrilateral element.
Okay, okay. They haven't shared there, and I don't think they will use that in assignment as well.
No, in assignment it was not there, but to just
there.
use it and check it.
So maybe they will share in due course.
Maybe.
I haven't got it yet.
Okay.
Any more doubt? Anyone else having doubt in class or today's lecture? So that's all I have for today. If you have no further doubts, you can leave. I'll wait for 5-10 more minutes so that if you have any problem, you can ask me.
Yeah, I will leave. Thank you.
Okay, thank you.